Hello everyone. Today I'm going to solve 5 difficult questions of algebra section in SAT Math. So heading on to the first question. A window repair specialist charges $220 for the first 2 hours of repair plus an hourly fee of each additional hour. The total cost for 5 hours of repair is $400. Which function f gives the total cost in dollars for x hours of repair when x is greater or equal to 2? Okay, so we know that the first 2 hours are always $220. So the function f of x is equal to 220 since it's the first 2 hours plus an additional fee, an additional hourly fee, which we would just use the variable k for it since we don't know, multiplied by the each additional hour. But since we know that x is the hour of repair, we need to do x subtracted by 2 because we need to disregard the first 2 hours. And in this case, 5 hours of repair was $400. So this is saying that when x equals 5, the whole function is equal to 400. So 400 is equal to 200 plus k, 5 minus 2. 400 is equal to 200 plus 3k, not 200, 220. So 3k is equals to 180. And dividing both sides by 3, we get 60. So the additional fee is $60 per hour. So our final function would be plugging k back into the original. We get 220 plus 60 x minus 2. If we just expand this, we get 60x plus 220 minus 120, which is equal to 60x plus 100. So our final answer would be A. The next question, these are all application questions, so you just have to read and understand the questions. Hector used a tool called auger to remove corn from a storage bin at a constant rate. This constant means that the function would be linear. The bin contained 24,000 bushel of corn when Hector began to use auger. After 5 hours of using it, 19,350 bushels of corn remained in the bin. If the auger continued to remove corn at this rate, what's the total number of hours Hector will have been using the auger when 12,840 bushels of corn remain in the bin? So since we know that this is at a constant rate, we can easily find how much bushels of corn that the auger removed per hour. So since we know that the starting was 24,000 and after 5 hours was 19,350, subtracting these bushels and dividing it by 5 would give me the average corn removed with auger. So this is if you could plug this into calculator or just, but this would equal to 4,650. And if we put this in our calculator, we get 930 bushels per hour. So we are finding how many hours Hector has used it when 12,840 bushels of corn are left. So the original minus the final, if we do the calculation, would equal to something like this. And we divide this by our 930 bushels per hour to get how many hours it took for him. So 11,000 160 divided by 930. This cancels out. And I will just put this into calculator. We get 12. So 12 hours of work was needed to get from 24,000 bushels to 12,840 bushels. So our final answer is D. The next question. An economist modeled the demand Q for a certain product as a linear function of the selling price P. The demand was 20,000 units when the selling price was $40 per unit, and the demand was 15,000 units when the selling price was $60 per unit. Based on the model, what is the demand in units when the selling price is $55 per unit? So, since we know that it's linear function, we also know that when the selling price is $40, the demand was 15,000. And when the selling price was 60 per unit, the selling price was, oh, I messed this up, 20,000 here and 15,000 here. So we can find a linear function, a linear line equation off of this. So the slope would equal to 60 minus 40 change in x over change in y. So minus 5,000 over 20, this will give us negative 250. So the demand Q equation would be negative 250x and plus B. We could just substitute 1 in to find B, 250. So 20,000, if we move this to the right, plus 1, 2, and then 100 is equal to B, and B is equal to 30,000. So now we get the whole equation, which is negative 250x plus 30,000. And the question is asking the selling price of when the selling price is $55. So that is the x value. So Q is equal to negative 250 times 55 plus 30,000. If we plug this into our calculator, this is negative 13,750 plus 30,000, which gives us $16,250. And that would be our final answer for this question. So we got 2 more to go. A certain apprentice has enrolled in 85 hours of training course. The equation 10x plus 15y equals 85 represents this situation, where x is the number of on-site training courses and y is the number of online training courses this apprentice has enrolled. How many hours does each online training course take than each on-site training course? So we got 2 variables and a lot of information is not given, but if we understand the question, this is like a 5-second question to solve. So x is on-site training, number of, and y is equal to number of online training. So 85 indicates the hours, so the total hour would be the number of on-site training multiplied hours, adding on to the number of online training multiplied by hours. And these hours are just these 10 and 15. So this is basically saying that On-site training goes on for 10 hours for each, and online training goes on for 15 hours. So this is basically just 15 minus 10, which is equal to 5. That's the difference. That's how many more, 5 more hours of online training course than on-site training course. That is our final answer to this question. So the last question. Adam's school is 20-minute walk or 5-minute bus ride away from his house. The bus runs once every 30 minutes and the number of minutes W that Adam waits for the bus varies between 0 to 30. Which of the following inequality gives the value of W of which it would be faster for Adam to walk to school? So we're trying to find the wait time, which is the W, so that walking to school is faster than riding the bus. So the total time of taking bus is equal to the 5-minute bus ride here plus the wait time W. And the total time for walking is just 20. And we want it to be faster for Adam to walk. So the inequality would have to be bigger to the bus side so that walking is faster and the time is less. So this inequality is just D. We don't even have to find for W. So D is just the final answer. So I have quickly went over 5 different application problems of algebra. I hope this helps for your SAT and I will see you in the next video. Thanks.